Good morning, everyone. Today we are going to present our research entitled Truck Cycling Efficiencies Analysis in Mining Operations by Comparing Linear and Nonlinear Machine Learning Models. This study focuses on improving mining productivity by predicting the truck cycle time using various machine learning models. By comparing both linear and nonlinear approaches, we aim to identify the most accurate model for supporting operational planning and decision making in mining activities. Now let us begin in the introduction. Before we begin, let us introduce ourselves. My name is Arif Ong, and together with Sabrian Zuhair, we conducted this research as a team. Okay, next is we going to the introduction. Mining productivity, mining productivity is highly dependent on the efficiency of truck operation. A truck cycle consists of four main stages: loading, hauling, dumping, and returning. The total duration of these activities is known as the truck cycle time, which directly affects production efficiency. At PT ANTAM Tayan, the type production target is approximately 10,000 WET metric ton per day. However, wait, operational uncertainties such as road condition, traffic congestion, and varying hauling distance often results in inconsistent cycle times. Additionally, mining operations are conducted across multiple pit locations, including Korea, Oman, Ecuador, making operational planning even more challenging. Therefore, accurately predicting truck cycle time is essential for improving productivity and optimizing dispatch decisions. And next, we are going to the theory. The theory is, before discussing our research, it is important to understand the theoretical foundation behind the study. First, truck cycle time is considered one of the key performance indicator in mining operation because it reflects the efficiency of the hauling process. Second, machine learning provides a data-driven approach for predicting operational outcome because based on historical data. In this research, we compare both linear models, which assume linear relationship between variable, and nonlinear models, which are capable of capturing more complex patterns within operational data. This comparison helps determine which modeling approach is more suitable for predicting truck cycle time. And this is the research objectivities. The main of this research is to compare the predictive performance of several machine learning models in estimating truck cycle time. We also aim to identify the model that provides the high prediction accuracy and can be effectively applied in real mining operation. The expected contribution of this study is to provide practical insights for operational planning and truck dispatch optimization using a data-driven approach. Furthermore, this research may serve as a valuable reference for future implementation of machine learning in mining operational system. And now we're going to the research gap. Although many previous studies have applied machine learning in mining operation, there is still a significant research gap. To best to the best of our knowledge, no previous study has systematically compared 5 different machine learning models using single real-world truck cycle dataset. Our research addressed this gap by utilizing operational data from PT ANTAM in Tayan and evaluating multiple machine learning models under the same experimental conditions. This enables us to identify the most suitable model for supporting dynamic truck dispatch and operational planning. And then we're going to the conclusion. The target in this research is truck cycle time. Truck cycle time, it refers the total time required for a dump truck to complete one full operational cycle, starting from loading, followed by hauling, dumping, and finally returning to the loading point. Since truck cycle time has a direct impact on production efficiency and equipment utilization, accurately predicting this variable can help mining companies improve scheduling, optimize resource allocation, and increase overall operation. Okay. Then this is mine, and we're going to the Sabrian Zuhair.
Hello everyone, let me introduce myself. My name is Sabrin Zoyer and I will explain to you our research workflow to the conclusion of our uh, paper. So this slide illustrates our research workflow. We start by collecting operational data from ANTAM Tayan Site. After that, we perform data process and exploratory data analysis to prepare the dataset. The data was then split into training and testing sets, followed by training 5 machine learning models. Finally, we evaluated and compared all models using the same testing datasets. And then we compared 5 regression models representing both linear and nonlinear approach. Multiple linear regression was used as the baseline model, while the decision tree, random forest gradient boosting, and artificial neural network were selected to capture more complex nonlinear relationship. This comparison allows us to evaluate whether more advanced models provide meaningful improvement. Uh, to evaluate model performance, we use three regression metrics: R squared, mean absolute error or MAE, and root mean squared error or MSE. A higher R squared and lower MAE and RMSE indicate the best prediction accuracy. Uh, Among all models, gradient boosting achieved the best performance with an R squared score of 77.57%. However, the improvement over multiple linear regression was only 0.66%, indicating that the relationship between operational variables and track cycle time is mostly linear, with some nonlinear patterns. Uh, Feature importance analysis show us that road condition is the most influential factor affecting truck cycle time. Other important variables include weather condition, traffic level, hauling distance, and truck speed. This finding can help mining companies focus on the factors that have the greatest impact on operational efficiency. Although gradient boosting achieved the highest accuracy, the improvement was relatively small compared to the linear model. On the other hand, multiple linear regression is much faster and easier to interpret. Therefore, we recommended using MLR for real-time dispatching and gradient boosting for offline planning strategic analysis. Finally, to conclude our research, we compared 5 machine learning regression models for predicting truck cycle time using real operational mining data. Among all evaluated models, gradient boosting achieved the highest predictive performance with an R-squared score of 77.57%. However, the performance improvement compared to multiple linear regression was relatively small, approximately 0.66%. This indicates that while nonlinear models provide higher accuracy, the dominant relationship between operational variables and truck cycle time remains largely linear. Therefore, our main contribution is not simply identifying the most accurate model, but demonstrating the trade-off between the prediction accuracy, computational efficiency, and practical implementation. We recommended using multiple integration for real-time operational dispatch because it is fast, interpretable, and computationally efficient. On the other hand, gradient boosting is more suitable for offline planning, strategic decision making, where higher computational cost is acceptable. We believe this hybrid approach provides a practical and cost-efficient solution for improving mine operational efficiency. So that is our conclusion of our research paper. Thank you for your attention. Thanks.